Good afternoon, everyone. I will speak some words in English, and after, forgive me to speak a little about Portuguese, because we have Portuguese colleagues, and I have to say something also to them. Welcome to this 16th Portuguese Artificial Intelligence meeting. In the name of the Director, I'll give you a good welcome to this Congress, to this meeting, and to this city, old heritage city, that I hope that you have some spare time to visit and to know, because of its historic importance and also for the landscape that our island has, good and beautiful landscape. And I would like to, in first place, to thank you all for coming here and to participate on this meeting. It's very important for us because we have participants from 17 countries, around 100 participants. It's very important for us. It's very important for the university, for this campus, that you come here to discuss all the themes and all the subjects related to this more general subject, that is artificial intelligence. So, in this particularly difficult moment for our country and for our university, with not so much funds that we would like to have, in financial terms, we'd like to appeal to you to help us by putting together teams with our researchers here, that some of them will show you the work that they done and they are developing here. And we'd like to participate on this kind of programs and this kind of projects. We hope we have now the start of a new community programs. We'll start next year, and it's also an important meeting to trying to know better each other, to build some teams that will propose some projects and will do, in collaboration with our researchers from the University of the Açores, some projects and some also some developing of new ideas, and also in the area of teaching, applying our investigation to the teaching. So, I have nothing more to say in English. Thank you very much for coming, and I hope that you have here all the conditions to have a good work and a good journey, or not this one, also the others that are going to follow this one. Thank you very much for coming. Bom, em primeiro lugar, saudar os meus colegas de mesa, que esqueci-me Now I'm speaking in Portuguese, sorry. Que me esqueci de saudar em inglês, peço imensa desculpa, e, portanto, também queria dizer umas pequenas palavras. Principalmente agradecer, como já referi, portanto, a participação muito extensiva dos 17 países, com cerca de mais de 100 inscrições. É uma iniciativa importante para a Universidade. Nesta altura, como disse, é importante porque é uma maneira de nós procurarmos novas áreas de investigação, novas áreas de investigação aplicada ao ensino e novas formas de ensino que permite a abordagem deste tema. Quero dar e endereçar em nome do reitor os meus, digamos, os nossos agradecimentos ao professor José Cascalho, na pessoa da organização deste evento. É, como disse, de facto, uma iniciativa importante para a Universidade e é uma maneira também de expandirmos a nossa área de atuação e a nossa área de conhecimento também para estes temas. Queria também dizer que, como disse já em inglês, que este tipo de iniciativas permite o encontro entre as pessoas e normalmente permite aprofundar os conhecimentos que a gente já tem, muitas vezes por mail, outras vezes pontualmente, e isso permite aprofundar esses laços, conhecer novas pessoas e permite, como eu disse em inglês, a construção de novas equipas de investigação. Novas equipas de investigação podem ser parcerias, até protocolos, colaboração com outras instituições, que permitem e vão permitir, de certeza, estou esperançado nisso, a construção e elaboração de projetos de investigação aplicados e, provavelmente, temos agora a avizinhar o novo quadro comunitário de apoio, portanto, será uma altura excelente para que isso aconteça e permita, portanto, unir esforços no sentido de podermos apresentar projetos que, envolvendo diversas instituições, também envolvam a Universidade dos Açores e os nossos investigadores. Quero também agradecer à Associação Portuguesa de Inteligência Artificial, portanto, pela oportunidade e a confiança que depositou na Universidade dos Açores na realização deste encontro. É importante para nós e também é uma maneira de mostrarmos a nossa capacidade e também todo o trabalho que os nossos colegas, dando uma palavra em particular aos nossos colegas da Universidade dos Açores, fazem e que se propõem a apresentar no âmbito deste evento. E, portanto, nada mais me resta acrescentar. Aliás, que o Cascalho disse que eu tinha que ser relativamente breve e, portanto, se não, desejar-lhes um bom trabalho e suponho que estão reunidos todos os elementos para isso. Quer através deste evento, quer todas as atividades complementares que estão associadas a este evento, como seja demonstrações, como seja exposições, que vão decorrer em outros locais, suponho que ficará um marco deste encontro que perdurará por mais algum tempo, levando não só dentro da região tudo, e portanto para a região também é importante, suponho eu, e também estou convicto disso, pelo apoio que teve também financeiro, para neste sentido, é importante para a região, mas também é importante para que a região se projete fora, através da Universidade dos Açores, tudo o que aqui se faz e a qualidade do trabalho que é aqui desenvolvido. Portanto, parabéns pela iniciativa, muito obrigado pela confiança depositada nesta realização e desejo os melhores trabalhos e os profícuos trabalhos para os próximos dias. Muito obrigado.
I hope you'll forgive me for not standing up, but I'm very tired. The climate change is dramatic. Once you fly, just flew in this morning. Well, thanks for your kind words. I'll be briefer still, because I'm eager to listen to our first keynote. But before we do that, just the minimal or canonical preface. Well, first I'd like to thank the organizers because the EPIA, or the Portuguese AI conferences, have been running for about 28 years, every 2 years. And it's only the effort of organizers such as these, on my side, on the extreme side of the table, which make that possible. EPIA is a small association with about 200 plus active members. And to find out more about it, I invite you to visit its website. It's at epia.pt, epia.pt. There's more info there. There's going to be plenty of talk. Well, there has been already this morning. We've looked at the future. We heard about 5 PhD students pitching their future wares, but in a minute I'll just like to summarize my personal perspective on AI. We're writing the Moore's law. We've been doing that for about 40 years now, since Mr. Moore came up with a law, which every couple of years you double. Well, everybody will probably have a personal version of the law, but basically hardware has become incredibly powerful, and so has knowledge exchange with the web. Well, less than 20 years ago, and today, I mean, over the last years, you've seen incredible mobility. You see incredible power, on the cloud or not. And I think it's clear that we may eventually reach that singularity event, which Mr. Kurzweil forecast about 20 or 30 years ago, 20 years ago, I think. That moment where somehow computers will become globally more clever, whatever clever means, of course. Because once you begin defining intelligence, then suddenly you get into all sorts of complicated issues, like Turing's test, whether it's testing whether the computer is smart or the other human is stupid. So it's not a linear proposition. But just to conclude, this community, which is represented here in the middle of the Atlantic now, representing not just, well, mostly, of course, the work being done by Portuguese researchers and Portuguese institutions, but not only that. I think is clearly at the frontier of what machines can do, not just software. Well, machines are software, and I just recall a couple of milestones. I mean, the best chess player was overrun 15 years ago, I think, more or less. Kasparov with Deep Blue. Jeopardy, that TV contest in the States, which requires substantial trivial knowledge. Well, not really trivial because it's rather tricky. Took IBM several years and a huge budget to beat. And so I think those milestones are going to accelerate. I'm a little bit optimistic regarding the progress, the rate of progress. Of course, good tools can be used, in a good or in a bad way. Finally, a little bit of a chauvinistic pitch. As you all know, Portugal, with a few other European outcasts, such as Greece and Italy and Spain, and by the way, France, to a certain extent, and Ireland. We do need technology boosts to deal with the other things that the Far East and the Russia and Brazil and India, all those countries have things which I will not mention by name in large quantities, which we do not. And if these countries to survive, to persist beyond its almost 9 centuries of history, it would be good to have something dramatic happening on technological front. That's my personal wish for this week. That somebody comes up with something really outstandingly good for the country. And with this national note, I pass to Luis.
Good afternoon. I do not promise to be brief because I may risk something otherwise. I'd like to start by to thank the University of the Açores for hosting the conference here. And also the support of many regional institutions that José Cascalho is going to talk about soon. This is the 16th EPIA conference, and we've, in terms of the program committee, we've tried to maintain its international character that the conference has tried to have since the beginning. And I think it's an important issue that is reflected in the participants, of course, but also in the program committees that were prepared for each thematic track. Well, we tried also to maintain the EPIA with a wide perspective on work and research being done in AI. And this is reflected not only in the variety of thematic tracks, we have 10 of them in different subjects, plus the doctoral symposium on AI that is already an event associated with EPIA for some editions now. But also that is reflected on the scope and variety of the invited talks that we have the pleasure to host, of Carla Gomes right next, Anna Paiva and Maria Fazli, and then Kenneth Stanley on Thursday. Moreover, there was already another event today besides the doctoral symposium. That was the challenges, and this I must say it was a very interesting and original idea of the organizing committee that always, since the beginning of the organization, expressed the will to try to establish bridges between AI and the local community research, and in the sense that we could have a cross-disciplinary interaction. And the event occurred today, right before the official beginning of EPIA, and it was, I must say, a success, not only in my opinion, but in the opinion of some of you that I've talked to. So this is a compliment that it must be made to the organizing committee already for this initiative. Apart from that, I will finish saying it's a pleasure to be here, and it's a pleasure to have your company here, and I hope you all enjoyed the conference. Thank you.
Some short notice about the more scientific process of the conference concerning the submissions and reviewing process. This conference had 157 contributions received from 31 countries. These countries included not only Portugal, but also Argentina, Belgium, Brazil, Canada, China, Colombia, Czech Republic, Finland, France, Germany, Hungary, Iran, Ireland, Italy, Japan, Mexico, Nepal, Netherlands, New Zealand, Norway, Pakistan, Poland, Portugal, Romania, Singapore, South Africa, Spain, Sweden, Tunisia, the UAE, United Kingdom, and the United States. It was quite interesting to see that the international content of the conference was quite good, with more than half of the submissions including authors from countries abroad Portugal. Concerning the reviewing process, each submission was reviewed by at least 3 and on average 4 members of the International Program Committee, with a total of 45 papers being accepted for the main Springer proceedings and 41 papers being accepted for the local proceedings. We have to express our appreciation for the work not only of the track organizing chairs, but mostly to the people from all the program committees from the different tracks, and to the organizing committee for all the scientific arrangements also, and all the reviewers without whose work the conference will not have been possible. So thank you all.
Okay, thank you. It's my turn. I will speak about local organization, and I will say something about what's going to happen next few days here with us. Well, let me say something about the history of this conference. It starts with a challenge made by Helder Coelho. So if everything goes wrong, please ask him. Because he said that Azores was the only region in Portugal that had never welcomed EPIA. So we decided that, okay, if you say that, let's do EPIA in Azores, and we select Angra do Heroísmo, and we are here here because of that. This endeavor would not have happened without the contribution of a lot of people, but particularly to the local organizers, Luís Gomes and Elia Guerra, that accepted this idea with the condition of having the venue here in Angra do Heroísmo. They came from São Miguel. This is another island. Azores have 9 islands. Okay, so there are some fights between Terceira and São Miguel. So this is quite astonishing. 2 people from São Miguel say, but please do it in Angra do Heroísmo. I don't know what they thought about this, but I will not comment any more about it. The local organizing team was complete with Pedro Cardoso. Pedro Cardoso is now in Finland, so we have an international team, local team here working in Angra do Heroísmo. Along this, we have already a long day and with CDA and also challenge that were already mentioned here. Let me say that we had first in the morning short papers, and then we had a special track called Azores Scientific Workspace Meets Artificial Intelligence. Well, the goal was to empowering possible research opportunities and new research projects, and I think part of the goal is already succeed. And so I'm very grateful for all that have been present and who accept this challenge. I will say the names because this event is now ending. Elder Coelho, António Menezes, who couldn't come at the last moment, João Luís Gaspar, Guy Menezes, and Paulo Borges. That was our guests that accept this challenge. Let me talk about the sponsors. We acknowledge the Governo Regional dos Açores, Azores local government, represented here by Dr. João Gregório, who is there in the front. And also the Fundação Luso-Americana, FLAD, for their financial support. This FLAD is also the Associação para a Mobilidade Antero de Quintal here in Azores. We also have to thank to Câmara Municipal de Angra do Heroísmo, and also to the Centro para a Ciência de Angra do Heroísmo, is a science center in Angra do Heroísmo. And with respect to institutions, we have here a few institutions that collaborate with us. There is the labs, the Lab Mag, the LIAC. This is the institutions from Lisbon, LIAC institution from Porto, the biodiversity group, CITA, here in Terceira, and the CMATI, this is a group of São Miguel, and also the University of Lisbon, and the Education Department that is represented here by Pedro Gonçalves, and the University of Minho and University of Lisbon. So a lot of people have been contributing to this conference. I have a word of gratitude also to Noé Rodrigues, who is sitting there controlling the sound and the image, because it turns possible to have online streaming of this conference. I would like to, I think we still have 5 minutes. I like to present now the easy part is to show what's going to happen during the next days. It's better for me to show like that. So, yes, I don't know if you can see. If you please, you can. Okay. Oh, thank you. So, right after the talk of Carla, we'll go to the cocktail. We are all invited for a cocktail to drink it, to discuss what Carla said to us. Next day, we start the conference as it is usually with different tracks at the same time. So we have 3 tracks, and if you look at the image, you start counting, you start 1, 2, 3, and start and say 4. And you say, oh, I can't count. No, there are 4 because we decided to create a demo session. This demo session, we decided to create, to have a specific room for this demo session where people that present their papers can combine, can decide, and go there and show their software or hardware in a more private discussion to the people that are interested. We also have in the demo session 3 companies that show their software, and so you should be there if you can. And so this is new, and so I ask you to see what's happening, and we will say to you all the days what will be happening in this room. The rest, I think you already know. The lunch will be at the same place it was today, so it's the next building in the other side of the road. And then we'll have a coffee break, and we'll have the social event. The social event, as you know, have free choice. You can go to the sea, you can go to underground, or you can just walk through the city and see the views and also see the important buildings of the city. So you have to choose, and you have to choose in the desk, in the registration desk. The next day, there is an interesting thing in social event. Let me check okay, I still have 2 minutes. In the end of social event, all people go to different places, but in the end we will meet all in museum, in the Museum of Angra do Heroísmo, where we will have some wine and some cheese and some bread and some cakes. So if I don't know what's going to happen, because if the people that go to see usually came with a lot of, need a lot of food. So let's see what happens, but I want you to share your experiences. Please take photos and share to each other what happened during this evening. The next day will be, sorry, I didn't told that Ana Paiva will be the keynote tomorrow, and Wednesday will be Maria Fajli, and then we'll have the session as a normal session. It is, and finally we have a EPIA meeting here, and then we have the conference dinner. The conference dinner will be at the fort, and there is buses to the place, and the buses were waiting at Terceira Mar Hotel, okay? At the nearby, the Terceira Mar is just, you go down, and the buses will will wait for you until 7:45, and the dinner will start at 8 o'clock, okay? So if you want to take a bus, you just go to Terceira Mar Hotel. If you can go by walk, if you are in the town center, it's easy to go by walk. Please go to the registration desk to ask for where is the conference dinner. Finally, we have the Kenneth Tanley as a keynote speaker, and then in the end we have a farewell meeting here in this room, in this auditorium. Let me say the last thing, all the social event, all the free options for the social event starts here in the university. So you just have to wait. People that go by walk wait. The people that it will start here, and people that go by bus, the bus stops here and wait for the people, and people that go to the sea, the company that take the people to the sea will have cars and take you to the boat, and it starts here, okay? Finally, let me show you something more. We had not during this last month, this conference was also something for the children and the kids in the school. We bought some robots with the help of the Centro de Ciência, the Science Center of Angra do Heroísmo, and they built robots with Lego robots and made experiences. So now in the Science Center of Angra do Heroísmo, we'll have an exhibition about intelligent robots. They are very small robots, you know. We made this with collaboration with LabMac. And so please, if you feel comfortable, please you go and visit the Centro de Ciência. We'll tell also in the registration, well, where is it, the place, okay? Thank you all. Welcome again. And now Carla Gomes will
give her talk.
Okay, so we have the first invited speaker of EPIA. Professor Carla Gomes is a professor of computer science in Cornell University in the United States, with also appointments in the Department of Information Science and Dyson School of Applied Economics. She has been doing research in optimization, operations research, and search methods in general. And recently she has been interested in a new field of computation sustainability. And this field has already also been promoted by the own University of Cornell, which opened a center or an Institute for Computation Sustainability, of which Professor Carla Gomes is the principal investigator. She's also a fellow of the AAAI, and today she's going to present us a communication entitled Challenges for AI in the Computational Sustainability. So we are looking forward to listen to Professor Carla Gomes. Please welcome her.
Yeah, because of the sound tracking.
Oh, okay, that's one. Well, thank you so much for the introduction, and thank you for the invitation to you and to the organizing committee. It's an honor and a great pleasure for me to be here. It's wonderful to be back home. This is my home in Portugal.
Tenho que falar diretamente.
Oh, okay. Sorry. So it's wonderful for me to be back home. You know, Portugal will be always my home. And it's wonderful to see familiar faces. In fact, the first one, when I got here, one of the first faces that I saw, Elder Coelho, and since we are blaming Elder for everything, I'm also going to blame him and quote, and say that he is in part responsible for my career in AI. In fact, I took my first course, AI course, from Elder, and both Elder and I did our PhDs in Edinburgh. When I got to Edinburgh, I remember they told me, well, you know, Portuguese, we've had outstanding Portuguese standards, so you better keep the trend. So that's what I've been trying to do. So today, I want to talk to you about computational sustainability. This is a very exciting new field, and there are exciting opportunities. I have to say the session before this session was an amazing introduction to the field. And let me start by thanking the members of the Institute for Computational Sustainability for you know, the many contributions towards the vision for this new field of computational sustainability. You probably recognize some of the faces. Actually, let me set the timer here. So you probably recognize some of the faces: computer scientists, for example, John Hopcroft or Tom Dietrich in machine learning or Bart Selman in reasoning. Steve Strogatz is more applied in math, but you probably know him from the small world. But the point that I want to emphasize is there are many faces that I don't expect you to recognize because they are biologists or economists or sociologists, etc. And this is really a key issue that characterizes this field. It is a highly interdisciplinary field that really requires multidisciplinary teams to, attack these very complex problems. I have to say that about 8 years ago, or for the last 10 years, I've been interested in sustainability questions. Pre-tenure, you have to be a little careful when you do applied work, but that was an area that interested me. 5 years ago, the National Science Foundation, the U.S. National Science Foundation, launched a major program for computer science called Expeditions in Computing. And the idea was to give researchers, a decent amount of money, $10 million, to perform research with the goal of advancing the state-of-the-art of computer science, but hopefully also with societal impact. This was a very competitive process. Everybody, MIT, Cornell, Stanford, everybody was applying to this grant. And that's where, we thought, wow, this is an amazing opportunity for us to put forward this vision of pushing forward this field of computational sustainability. And we were lucky. We got this fantastic grant, and that really allows us to, do research in this area at a whole different scale. And you will see that we address several issues in terms of research, but also education and outreach. Well, what I want to emphasize is that, and in fact, for example, for this NSF grant, we really needed to show that beyond societal impact, we had to perform transformative research. I have to say, I don't know if you are familiar with probably not, but the word transformative actually is a made-up word by NSF. It doesn't exist in English, but we know that we have to use it to really state how our research can be transformative, and we need to demonstrate that. And what I want to really put across in this talk is exactly the fact that this is truly a two-way street. On one hand, we hope that computational thinking, algorithms, and methodologies will impact sustainability fields, but from a computer science point of view, it's incredibly exciting because, the unique scale, complexity, and magnitude of sustainability problems are really quite challenging and lead to fundamental new questions that require us, computer science, to develop new algorithms, new methodologies that in turn are going to be applied to the sustainability problems, but to many other fields. And this is actually very important because, computer science, typically they want to be and remain computer science, and therefore it's very rewarding to see that research that they are doing, for example, I have students who are developing methodologies and developing policies for managing fisheries. The same student is using exactly the same not exactly, but the same methodology and the same algorithms to manage the battery of an electric car, or to try to infer the decision process of pastoral tribes in Africa, etc. So this nature, computer science, we know how typically we study these problems that are going to be applied across different areas. That is really exciting. So let me give you a bit of, I'm sure you probably are familiar with the sustainability, but very briefly, I want to give you a background, and especially because this initiative was started by a woman, so I thought I would really emphasize it. In '87, actually, Brundtland was chairing this committee, the United Nations World Commission on Environment and Development, and basically they stated for the first time, and they raised serious concerns about the state of the planet. But, they also introduced the notion of sustainability and sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their needs. Well, from a computational point of view, there are already implications, because if we need to plan now thinking about the future, that means that we really need to think in dynamical terms, which introduces several levels of complexity. More recently, in 2007, the IPCC, the Intergovernmental Panel on Climate Change, reiterate the concerns raised by the Brundtland report, that is also referred to as our common future. And in fact, they state that the situation deteriorates dramatically. They mention several indicators: global warming, erosion of biodiversity, etc. And in fact, they won the Nobel Prize. They also emphasize the fact that sustainable development is really not just about the environment, or just about energy, or about a particular aspect, or just global warming, etc. But it really encompasses balancing environment, economic, and societal needs. So basically, when we are dealing with sustainability problems, they are quite complex, and the unique scale and complexity of these problems, we can talk about a natural ecosystem or a man-made ecosystem such as the smart grid. That really leads us to very complex systems, in general dynamical systems that we want to manage and predict. In order to understand these systems, we collect large amounts of data. So typically, we are dealing with multiple scales, temporal and geographical scales. We are dealing with uncertainty and with many components or agents that interact in non-linear ways. So the level of complexity is really dramatic, and therefore there are many significant computational challenges. Not that many computer scientists study these problems. In fact, I was talking to Paulo, and he told me, I was so surprised to see a computer science interested in ecology. And we need more. We need more people working, addressing these questions, and therefore we need more people in this new area. So what I want to do today is I want to give you some examples, and I will be a little biased. I will talk about projects that we have at Cornell, at the Institute for Computational Sustainability. Then, that's poorly formatted, sorry. Then I will talk about how this initiative is really beyond us, how we have also invested a lot in terms of building a community and education and outreach, and then I will provide some conclusions. So I will give examples in different areas. I'll start with biodiversity and conservation, then I talk a little bit about some projects concerning poverty mitigation in Africa, and I'll wrap up with a very a project in materials discovery for fuel cells. And I'll start with biodiversity and conservation, even though I have to say that we had an excellent introduction to the topic. And in fact, as Paulo mentioned, one key question in biodiversity research is really the question of knowing how different species are distributed across landscapes over time. This is, a very challenging question, and I have to say that, and this is my recommendation, if you want to work in this area, I think it is important for you to team up with experts in that area, because you don't want computer science to, start speculating about problems when they know very little about. So it is important for you to have access to the specialists in the corresponding areas. So that has determined a lot the nature of the problems that I've been working on, because I really make sure that I have access to experts in the field. Cornell has a well-known lab of ornithology, and one of the programs that is quite exciting is, in fact, there are several citizen science programs. One of them is eBird, and basically this project gives, lets everyone interested in birds, they can contribute to research by submitting bird observations to this web portal. So this is quite exciting because, it has a tremendous scientific value. Humans are the best sensors in terms of recognizing bird species. We still don't know how to automate that, so it's very valuable information. That gives us data to try to plan conservation actions, but it also has a tremendous impact in terms of scientific literacy. James Watson started his career as a biologist by doing he was a bird watcher. Richard Feynman also loved bird watching. So based on that, first we actually have, eBird has over 150,000 volunteer birds that have collectively contributed with over 10 million hours in the field. 10 million hours is a lot. That is over 1,000 years. And with that, they have submitted over 140 million bird observations. By combining this data with environmental data, now there are a large amount of sensors, so the sensing technology is really providing terrific data. By combining this data and using very powerful machine learning techniques and also computational resources, we can now, and we were able for the first time to produce continent scale distributions that reveal patterns that we didn't know about. In fact, you see there, that is the occurrence of indigo bunting, and you see for the bird arrives in the US around, I think it's end of February, then it goes north, and around June, it starts moving south again and leaves the US around October. Well, with the data, we were actually able to perform a study of over 400 species and with very detailed resolution, and really that gave us a first assessment of the contribution value of public lands to the conservation of birds in the U.S. In fact, this report is officially released by the Secretary of Interior. We participated in the computation effort, but with many other organizations, and obviously the Lab of O, or Lab of Ornithology, was a main player. Well, one key question in terms of research is how do we estimate the species distributions? And in fact, this is an area that is gaining a lot of interest in AI, in machine learning. Maybe some of you know MaxEnt. MaxEnt was developed by Steve Phillips and Judik and Rob Shapir. You recognize probably the name of Rob Shapir. He's a well-known machine learner. There are many questions. For example, how to address spatial temporal issues concerning bird distributions. There are very interesting questions, research questions. I will just highlight. For example, when we are dealing with citizen science projects, we are dealing with observations submitted by 7-year-olds or experts, so different levels of expertise. So how do we infer levels of expertise? Wang King Wang and Rebecca Hutchinson worked on that. Another key issue is, for example, trying to understand migrations. This was actually a best paper at the CompSUS track at AAAI, based on eBird data, observations, acoustic and radar. Another question that is, quite interesting is how can I engage participation? How can I get the citizen science to submit more bird observations? And here, basically, we are using, the bird watchers submit observations, we get feedback. These observations are going to allow us to predict where the species are, and based on that, we can provide recommendations or where they should go to maximize the chance of observing the species, but while diversifying the sites and hopefully go to new places. This gives rise to interesting problems that we call probabilistic maximum coverage problems, and also topics concerning recommender systems. Here is an example. I'm going to emphasize that, for example, here we exploit some interesting some interesting aspects, even though this is one of those hard NP complete problems. It turns out that it's actually submodular. So with greedy approaches, we can guarantee that we are no more than 40% from the optimal solution, and in practice, the solutions are very good. Also, we are, based on these results, we can suggest new locations, because one key challenge here is that, people tend to submit distributions where they live. So that means in the middle of nowhere, where nobody lives, we don't have distributions. Therefore, there's a sampling bias that we have to correct. So this is a very interesting challenge. I thought I would mention there was another citizen science project at ICHCAI. The elder also mentioned the conference. There was, in fact, the theme of the conference was computational sustainability, and this is a project for the CICADA. Another challenge, obviously related to this issue, is the issue of climate change. Again, Steve Phillips gave a talk at ICHCAI, and in fact, we are collaborating with him, and in particular, Theo Dameles at Cornell worked on the computational modeling with Steve Phillips, studying how the greening of the Arctic that appeared in Nature Climate Change. one issue concerning that is really leading to biodiversity loss is habitat loss and fragmentation due to agriculture, urbanization, deforestation, etc. So biologists believe that in order to try to combat biodiversity loss, it is important to try to maintain landscape connectivity. We are working with the Rocky Mountain Research Station and USGS on trying to identify corridors for preserving different species. So to give you an example, here we have the Glacial Park, Yellowstone, and Salmon Solway. These are three main reserves, and the idea is that we would like to connect these reserves so that we can allow movement of the species. Well, this problem is really a graph theoretical problem where here we have, different parcels. The green ones are the reserves. There's an edge if a grizzly bear can go from one to another. And what I want to do is I want to find a connected component that will maximize the utility for the bears, but within my budget. This is one of those problems, again, that's known to be NP hard. So in the worst case, we only know of exponential algorithms that scale exponentially. But the reality is the real world, and we have shown that, is full of structure. So if we exploit it properly, often we can actually find very good solutions that are optimal or near optimal. In fact, for example, for this here, we were able to, by using several approaches such as, typical case analysis, identification of tractable structure, streamlining, etc. I will talk a bit about these techniques maybe later. We actually are able to find corridors that to prove optimality or within optimality, we are within 5% of optimality, and we could find solutions that are way, way less expensive than what was believed to be the case. I gave you this baby example as an illustration. We are actually expanding this for other species, namely for wolverines, lynx, and bears, etc. And one issue that I want to emphasize here is that computer science, we know network design is a key area of research for us, and finding, for example, the minimal corridor for grizzly bears connecting reserves, that is the Steiner T problem. Well, that problem is exactly the same problem as finding the way to connect computers for teleconference. So we are importing several ideas from network design, but by looking at these problems, for example, when we have multiple species, we need to really consider different requirements. What bears like is not necessarily the same as what the wolverines like, etc. So now we need to look at layered graphs, and therefore we need to extend the algorithms in the context of network design to address these specific factors, and what we are discovering is then these algorithms are also useful for networks and standard network problems, but also social networks, etc. And this is important and makes it also exciting for the students. And it is also, I have no problems finding PhD topics for the students because there are big N number of questions to address here. So it's very exciting. Now, I'm going to briefly mention that some of these ideas actually also carry over to address other problems. For example, we are working with several groups, Chris Barrett and several groups from the Institute for livestock research institute in Africa. The main issue is how to try to protect pastoral tribes and livelihoods against the risk of drought. So what we are doing is we are trying to develop models to understand the migrations of these pastoral tribes and, trying to infer the migrations of pastoral tribes, again, has similarities to try to understand bird migrations. So basically, we are using models very rich, using several data sources. And, for example, what we want to do is to help policymakers, and we've already started providing some results on that, where they try to help them decide where to locate water wells for the tribes. Another interesting question is how can we try to protect them against the drought? And one mechanism that is quite novel is this drought insurance, where basically the pastoral tribes get indemnity payments based on a vegetation index. So they don't need to, so the insurance company, they don't need to see the animals die to insure, to pay for a disaster. It's based on this, when the vegetation index reaches a given level, very or dramatic, or I'm not sure what the level is, but they automatically provide the payments. And in fact, they've already provided automatic payments to the herders in 2011 when there was a severe drought in Kenya. There are many, many exciting research questions here, and I put different areas, natural science, social science, and computer science, ranging from climate, how can we try to track the animals. Elder also mentioned game theory questions, because a lot of these tribes, there are tremendous conflicts. So there are very challenging and interesting questions for computer science. So what I wanted to do now is I'm going to talk about a completely different area, but I will try to actually give you a bit of technical detail. And I think this is super exciting. I mean, all the areas are exciting. It was, but it's almost serendipity how you end up working on different topics. And basically, Cornell has has a synchrotron and has an institute on fuel cells, and they are trying to discover new materials for fuel cell technology. There was a report, DOE, the Department of Energy report, and basically they stated that the existing energy approaches will not be enough to secure our energy future. And in fact, we need new materials, and we need research in new materials. The White House recently, actually I think it was last year, had an initiative called the Materials Genome Initiative, and basically this initiative is to accelerate and reduce the cost of discovery and development of new materials. And here, this is the flyer they use, and you see that computer science is all over. I have to say, I came across this area because, in my interactions with the Center for a Sustainable Future at Cornell, the director is a material scientist, and he kept telling me, oh, you need to go and talk to to Tito Abruna, who is the director of an energy center at Cornell, and to see if there's an exciting project for computer science, because we believe that this is really there are many opportunities. And when Tito mentioned to me the area of combinatorial material discovery, that immediately rings a bell. Combinatorial, we like combinatorial problems. But on top of that, and that's, this is how the world works, it's not just in Portugal. My son used to play baseball. and one of his friends, also, on the team, his dad is a professor at Cornell, a material scientist too, and frankly, very quiet person. I never heard that many words from Bruce. His wife would do all the talking. Well, by coincidence, they told me, Bruce Van Dover is the material science you should talk to. And I said, I think I know him. And I met with him and with the postdoc, and he said, this is very interesting, but John, now I'm thinking, I'm here. John knows all about this, but he's very busy. So I'm not sure he's going to have time to talk to you. So, well, we met with John, and John said, no, if a computer science wants to talk to me, I know computer science can help me, so I'm going to make all the time. And it turns out Bruce was actually very talkative and very excited about this research, and that's how we started a collaboration, all these little, networks. And basically, I learned about how they do this, what it's called high throughput materials discovery, where basically, they collect a large number of samples, actually thousands samples of multi-element systems. And then, they are left with these massive amounts of data, and often, they use the synchrotron that has a very potent high beam to do the X-ray diffraction patterns, but then they are trying to infer structure from these large volumes of data, and it takes them a year to try to analyze one of the systems. So it's, I'm not saying continuous time, but basically by staring at some plots, they are trying to infer these patterns. As I mentioned before, this is part of the Cornell Fuel Cell Institute, and they are trying to find new materials with good properties. For example, for fuel cells, they want to find good catalysts. And in fact, recently they showed that platinum, a combination with platinum is very good, but the problem is platinum is very expensive. So at a high level, what they do is they have a silicon wafer, and they have guns, and they sputter 2 or 3 metals, and they bake this wafer at about 650 degrees Celsius, and then they use, because they cannot really inspect the materials, they use electromagnetic radiation to study the crystallographic properties of the film. Well, just to give you an idea, using the high-energy synchrotron source costs about $1 million a week. So it's important to try to speed up these experiments and automate the analysis of the data. As I mentioned before, recently they showed that a combination of platinum and tantalum really has very good properties, catalytic properties, but they are trying to understand why and hopefully to find other elements that are not as expensive as platinum with similar properties. So here is the problem. We have three elements, and basically what they do, I have a ternary view. For each point, they obtain a sample. This sample is going to be, for example, a combination of, in this case, we have 38% of tantal, palladium, and rhodium, I think. But you don't really see the crystal. So what you do instead, you do X-ray diffraction, and you get the X-ray diffraction pattern. So what we want to do is, based on the diffraction patterns, we would like to infer these different phases of the materials, because these correspond to really different materials. And in the end, this is an inverse problem where, based on the X-ray diffraction patterns, I want to infer crystal properties and identify the different phases of the materials. So here we have, these are the points that we sample, and basically I would like to identify the different phases. And here I have the different phases, and not only do I want to identify the different phases, for example, alpha and beta, so I want to label them. I want to know that this one is a mixture of alpha and beta. So basically, still a bit informal, but more formally, the problem is, given my input, the X-ray diffraction patterns, given additional physical requirements, because the physicists and material science actually know properties, how the X-ray diffraction patterns behave. For example, they know that a phase, if I have three materials, the combination we can have at most three phases. They know that the peaks, these peaks can shift, but they cannot shift by more than 50%, etc. So there are several physical constraints. We want to output, the different phase regions, and we want to be able to identify the pure regions and the mixed regions. So, you look at this is what? A clustering problem. It looks like a clustering problem, correct? And, that's what everybody has been doing, and they have tried clustering techniques. Well, so, by the way, we have this data available if you are interested in studying. And in fact, even all the other problems that I mentioned, our data is completely available, and our software, and everything we do is open source. So here is again our problem, and when we tried machine learning techniques, and in fact that's what they've used so far, what we realized is that the machine learning techniques, and in fact we developed new kernel-based techniques, they are good at giving us the big picture. Some of the techniques that we use that are effective at extracting some patterns are dynamic kernels based on dynamic time warping. Basically here what you do is you use dynamic programming to align the peaks and find similarities between the peaks. So these machine learning techniques are very good at giving you the global perspective of the clusters, but they fail miserably in terms of enforcing the physical hard constraints of the problem. So they don't know, they cannot enforce connectivity, they cannot enforce this, shift of the peaks, etc. Well, so basically what we decided to do was to actually approach this problem and combine, that has been a bit of the story of my life, really, to bring together different ideas from different disciplines, namely, AI, machine learning, reasoning, and operations research. And basically, what we thought that would be important is to combine machine learning techniques with probabilistic constraint reasoning to capture the constraints of the problems. I will get back to this. And in fact, let me say that we decide to write a formal model characterizing this phenomena, and this formal model really enforces all the constraints, and to our disappointment, it did not scale at all. 10 minutes? Okay. Thank you. So it doesn't scale, and in fact, we can analyze at most like 10 little points at the same time, which we are talking about here. We need many more points to analyze. So I know some people here, and now I'm going to speed up, now that I know that I have 10 minutes. I have done a lot of research in terms of satisfiability. I know some people are going to present satisfiability, and in particular also the exciting area of SAT modular theory, which is satisfiability extended with different theories, and we actually could perform way better than just CSP or MIP-based techniques. And in fact, what you see here is the ground truth. Here, the best existing approaches would identify these poor patterns, and with SAT, we could do much, much better. You see, this is very close to this. Quite exciting, but still, it takes considerable time. In fact, I have to say, this is really exciting, but it takes about 15 hours. But, I mean, it's quite good. Still synthetic data. So one question that we had was, well, can we actually do better? And can we use minimal insight from people to try to speed up this process? And in fact, I'm going to give you a very quick baby introduction to a whole new area of AI, that is the area of backdoors and discovering hidden structure. And to give you that explanation, I'm going to use a very simple problem that I have studied ad nauseam, but sometimes, and it's for the young generation, sometimes simple problems are very good. Here is an NP-complete problem that is completing a Latin square, which is a particular version of the Sudoku. You may be familiar with Sudoku. I have n colors, in this case 10, a 10 by 10 matrix, and I cannot repeat a color in a row or in a column. And if I solve these problems, this one is done, this one is done, this is still going. And statistically, what's the difference between this instance? This one, you see, took much longer. Can you guess what the difference is here? Why this one took longer? The algorithm? No. It's not the algorithm, but that's a good hint. Well, it is, look at the percentage of pre-assignment. That's the Sudoku, it's similar. There's a critical region, and you see that this is as a function of the percentage of pre-assigned colors. You see that this area, when you have only a few colors, it's easy for an algorithm to find a solution. When you have a lot of colors, it's also easy to show there's no solution, and the critically constrained area is here. Okay? And you see this phase transition. Well, just as an aside, this is a cute little problem, but it has actually applications in many areas. In Sudoku, which is very good. In fact, it's good for your brain to calm you down. But scheduling, fiber optical network, this structure occurs across different dimensions. Well, what's interesting is, one time, I remember had a high school student do this applet, and I knew that I had an easy instance, and basically what we did was we created a backtrack search algorithm, but this algorithm, in case of a tie, it would flip a coin to decide what color to color next, or what cell to color next, or what color to use. But the algorithm is complete. It can prove, find a solution or prove there's no solution. Well, if you solve this problem, again, there's something interesting. These guys are done, and that one, those two, are taking longer. And in fact, I was surprised to see that even in the morning when I woke up, I fell asleep on the keyboard, it was still running. So basically, and again, this is an algorithm that is complete. It only breaks ties randomly, but it is an exact complete algorithm. Basically, this led us, in fact, if you plot these the number of runs and the sample mean, you see how this goes up and down and keeps increasing. And the intuition is these are heavy tails. I'm speeding up, but basically the distributions that characterize this phenomena are power law. So the intuition is you should restart your algorithm. And in fact, you see that we discover that heavy tail phenomena in combinatorial search occurs across several domains, the latent squares, the planning, scheduling, etc. But it's really pervasive, and it actually also dinosaurs also have heavy tails. I did this when my son was a kid. He loved this. But the intuition was that, well, we should have complete algorithms that do restarts and are randomized. And in fact, all the SAT solvers nowadays use restarts. If you are familiar with the restart, with SAT solvers, the complete solvers use restarts. So basically then we wanted to try to understand how we explained that the same algorithm can take sometimes 1 minute to run, other times it can take hours. And then we looked at this idea of backdoors. Backdoors are sets of variables that capture the combinatorics of the problem. So once you set the backdoor, the rest of the problem is solved just with propagation. And we actually defined the concept formally, what the backdoor was, and we actually show that if you have a problem that has a small backdoor that's small enough, say log n, your algorithm is going to run in polynomial time. And we have shown that, backdoors, and many other people have done follow-up work, that backdoors exist in real world, and therefore that's why SAT solvers, and actually now even CPLEX is now introducing restarts and randomization, etc. Why am I talking about this? Well, just to give you an intuition, here is a very large a very decent instance that has it's not very large, but it has 840C variables. Here, after assigning 5 backdoors, you see the constraint network is already simplifying away. After 12 backdoors, you see how the instance is much simpler, and then you solve it trivially. Here is another example where even though you have about 400 variables, it's enough to look at 3 variables to prove that this problem has no solution. So one question that we have is, and people have had, is what's the semantics of backdoors? Can we actually try to find backdoors? And up till recently, we couldn't find backdoors unless the only way to find the backdoors is by restarting, and that's exactly what people do. They restart code. But, you know, it's a very interesting question to try to understand the semantics of the backdoors. So back to the materials discovery problem. Well, one of the questions that we had was, can we try to solve these problems, and is there a way for us to try to identify backdoors? And in particular, can we have humans help us, but using what we call human computation, but crowdsourcing this information so that we don't expect anybody to know anything about this problem, about the material science problem. And so that was exactly what we decided, you know, one key question. And we had two settings. One, a single user setting where we have well, na parte de cima. Mas isto tem de estar on, não? Eu tenho aqui outro, obrigada. So here you have the different points, and here we have a slice, and this is really the X-ray diffraction patterns, but now we use it as a heat map. And basically what we ask people to do is to identify patterns in this heat map. For example, here you see that these four little blobs seem similar, so it's likely, we give them a tutorial really in terms of blobs. Oh, if the blob, if they have the same length and this and that, this suggests a pattern. So we use Mechanical Turk. Are you familiar with Mechanical Turk? So Mechanical Turk is, Amazon has this Mechanical Turk where you can submit all kinds of tasks to people, ranging from, can you do my homework? Don't use it. To, can you proofread my paper? Can you annotate this paper? Can you label this image? So all kinds of questions, and you can pay, or you can, and typically they pay ridiculous amounts of money. I mean, really, like 1 little cent for a batch of work, but there are several people who still like doing it. And you can also, you know, put these tasks directly to your web page, and people end up discovering them, and there are some hackers. Are you familiar also with Foldit? Foldit is a game where people can play, and basically they are helping biologists to find the structure of how proteins fold. So, but we you know, putting this task on Mechanical Turk, in one day we had thousands of answers, and basically what we were surprised was not only, you know, this minimal input from people, really they could provide us really amazing insights in terms of the backdoors. And for example, this instance that without human computation takes 13 hours, with minimal information we could go down to 74 seconds to solve this problem. So this was very exciting, and as I said, for the first time we have a way of understanding the semantics of backdoor. So I'm going to wrap up. I just want to say that our group focuses on, you know, 3 main topics: big data, machine learning, constraint reasoning, optimization, dynamic control, and simulation, multi-agent systems, and citizen science. As I mentioned before, even though these problems, they look completely disconnected, often there are themes. For example, sequential decision making. I already mentioned that I have students working on policies for fisheries who are also working on policies for battery management. Also, for example, we are working on problems concerning the managing diffusion in networks, and again, these problems range from forest fires to diffusion of birds or invasive species, etc. I talked about citizen science, I talked about network. We are also, interestingly, this problem, we refer to this problem as a source separation problem. Basically, we want to identify the different phases. Well, this problem is very similar to trying, for example, we are working with biologists where we have the recordings of elephants in the forest, so we have all these sounds, and we want to separate the elephants from the frogs, etc. So from a computation point of view, the methodology, there's a lot of common processes here. Finally, as I mentioned, we have different activities. Obviously, we focus on research, but we also have education activities. We have exchange programs, so if you are interested in this research, let me know. We have doctoral programs, etc. We have also done a lot in terms of community building and in terms of impacting via programs, concrete programs with NGOs, etc. We publish in computer science mainly, but we are now working, publishing in other journals. And there's a large community. This is now way beyond us. The AI conference actually have a special track on computation sustainability. I encourage you to submit to the AI conferences. Last year, this year, the theme of the conference was computational sustainability. And these were 2 invited talks, and there were many problems addressing different issues. There's also a project on making this available online, creating an AI companion book. So you can also participate here, and you can blog, etc. There's a blog, all kinds of exciting initiatives. In conclusion, computation can support different areas in terms of decision-making process to address sustainability questions. And as I mentioned before, this is truly a two-way street. On one hand, we hope to inject computational thinking in terms of sustainability science and provide methodologies for computation for sustainability science. But it's also exciting for us because this is leading to new methodologies in computer science, and it forces us to develop new algorithms that in turn are applied to many areas, and also it increases the diversity in terms of computer science and engineering. I have a few more women as students, which is very exciting. I don't know how bad computer science is in Portugal, but in the US, less than 5% are women. So, well, this is, basically, to summarize, this is a highly multidisciplinary field. It's, computation sustainability is pervasive, and it does have, I think, a great potential to advance the state of the art of computer science with the bonus of, hopefully, we also have unique societal impact. Thank you.
I was curious about this, on one hand, crowdsourcing, and on the other hand, what augmented or human computation. That is one of the recent areas of expansion, let's say, of artificial intelligence, is in the sense of having working as online auxiliary of human work, so that we can use the computer to test stuff that is difficult for us, but that the computer can do number crunching very easily. And then this, it's connected with that. You just mentioned it briefly. Maybe you'd be, yeah.
Yes. Yeah, that is actually a very, a new research area, and you probably have already done a lot of that. You may be familiar with things like CAPTCHA. Do you know what the CAPTCHA is? And basically, CAPTCHA, when you try to log in, and they give you these distorted words, and you have to prove that you are a human. Because they don't want, just bots searching the site. You need to decipher that word. Are you familiar with that? So you are actually doing work, because basically this area was started by Louis Van An at CMU. Basically, they use this. They have a project with the New York Times where they are trying to translate, and they have the New York Times going back from. Oh, sorry. This is the timer. So, so I was on time. yeah. Sorry. But basically, when you do the CAPTCHA, you are really trying to tell them what the word was, because they use words from the New York Times that cannot be, OCR does not process them, and so you are helping them. But the area of human computation now is growing, and in fact there's going to be the first conference in September, and the idea is there are tasks that indeed humans are better, like vision tasks, or we have, for us, this is very easy to identify, for example, a bird, but for a machine, it's not. So you use human capabilities to help you solve tasks, the tasks humans are good at. That's what we did here. We use the humans just to tell us very briefly to identify the patterns, and they don't need to know anything about the material discovery. And this is a very exciting area. It's also citizen science. I can give you, there are many examples of human computation tasks, the CAPTCHA. For example, when you play games, Google actually, where you play a game with someone to label a picture, where basically you are working for Google, labeling, saying here this is a picture of, a beautiful landscape or whatever, so, or a bird, or all these games. In the end, you are just labeling pictures. So it's a very exciting area, taking advantage of the skills that natural intelligence, that we don't even think there's intelligence when we recognize a picture or any other related tasks, but that will help the computer to solve other tasks. Pardon? Can we beat NSA? Oh, NSA, don't even mention that. It's very sad what's going on there. But, yeah, so those are challenging questions. I'm not... The
problem is Google image. There is Google behind, so they have this central, they are the central stuff there, but otherwise it's not.
When we don't have any Google or New York Times in your examples behind to tell people what to do, this is I think the biggest challenge. How do we self-organize, so to say, to... do these
How
tasks?
you mean how do you create? I mean, you know, in fact, like they use the mechanical Turk now for all kinds of tasks, including, for example, for machine learning to label text or to label. So I mean, there are many opportunities for you to use human computation. For example, we are planning to use. You know, I mean, citizen science is another example of, you know, for birds, for identifying stars, or for, there are so many opportunities to use human computation, citizen science. And for, what is your research area? Pardon? Multi-agent systems. There, I'm sure there are many opportunities for you to create your own data and, you know, have somehow, you know, input from humans. And obviously, multi-agent is a very exciting area. Any
other questions?
So I think now that I understood your main message, so it seems that the main problem nowadays is how to deal with big data. And it's not just NSA, fortunately, for us. But it seems that your answer is just to put the human in the loop in order to help. Is that so?
Well,
in some way.
My answer is, you know, combine whatever all the resources you have. For example, for materials discovery, we are not just, you know, just using the human would not solve. We are using very powerful machine learning techniques, but machine learning techniques, they are not also
enough.
the answer. And in fact, no. And in fact, machine learning techniques fail miserably. So we actually are building very sophisticated models and using techniques from, you know, optimization, satisfiability, etc., to capture the richness of in fact, in general, when we are dealing with scientific domains, you do need to enforce background knowledge, you know, the physics of the problem, etc. So you need, you know, principal models, formal models. But, you know, it's, in addition, we actually could solve, for example, the example that I gave you, we can solve the problem taking several hours. Well, it turns out that with minimal human input, you know, we discover a lot of people from Russia are playing these games. I only show you the mechanical Turk. We are also developing games, etc. With minimal input, you can actually accelerate the computation dramatically.
But can you generalize from that example?
Can I generalize?
Can you be sure that human in the loop always help you in going?
Not always, but
maybe the opposite.
Sometimes, yes, sometimes that's true. But for some problems, for example, problems where vision where identifying visual patterns, that is, you know, I think, in fact, they say that I think most of the computation we spend is with our visual cortex. So we have perfected that over, you know, millions of years, and we take advantage of that. So indeed, this is one of the domains where humans seem to help.
Thank you.
Thank you. So let's thank again Carlo for her.
Oh, sorry.